Hi, everyone. Welcome to the Tom's Hardware Podcast for today, August 29th, 2023. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch. I'm joined by Raspberry Pi expert Ash Hill and our very special guest, Dr. Footleg, Paul Fretwell. Dr. Footleg, tell everyone about yourself.
So I'm a maker, Raspberry Pi robotics enthusiast. I've been a software developer for most of my career in the life science sort of software for drug research industry, but I do a lot of Raspberry Pi stuff for kind of educational outreach to encourage children into careers in STEM subjects, science, technology, engineering, maths. And that was what kind of drove me to design and build Raspberry Pi robots and other projects which kind of inspire and entertain.
Awesome. So, what are some of the projects? What are some of the projects that you've worked on lately?
So most recently is actually this little robot, which is a culmination of doing a lot of robotics at events where I let children drive my creations, and the robots have to take an awful lot of kind of hard knocks when you put them in the hands of the public. And this robot is an attempt to improve on the kind of both the robustness in terms of resistance to getting damaged, but also things like power. So one of the problems is always that when the batteries run flat, a disappointed child hands you back the robot and said it's stopped working. And what I've done with this design is I've actually made it so it takes a kind of standard form factor commercial battery. And so I can literally just pull one out, slot another one in, and they're back up and running in seconds. So that's my kind of most recent project.
I love the tread. Instead of wheels, I love the tread. That's good.
So these were a kind of Pololu track set, which was actually one of the earliest bits of robotic kits I bought. And it sat in the parts bin, not getting used because other projects kind of came along. And so finally, I've kind of taken kind of one of the newest robotics boards, the Pi Moroni Inventor Hat Mini, and paired it up with some of my oldest hardware. And that's what the resulting, and it's still under development. I 3D printed new parts for this yesterday, which is kind of to address some of the problems which I had with the first prototype, just kind of like making some minor improvements, try and get a better fit, a bit more track tension, things like that.
What do you call that robot? Does it have a name?
Unimaginatively, I've been referring to it as triangle tracks. So I give my robots names in terms of giving the Raspberry Pi a name, so when they're on the network, I could see which Raspberry Pi it is. And so this one's currently called Triangle Tracks.
What do you use to control it?
So all of my robots, I use these sort of PlayStation controllers paired over Bluetooth because it's very easy to set them up. And once they're paired, they don't talk to other robots. Whereas a lot of the controllers which pair with dongles will pair to the nearest dongle they see, which is fine when you've got one robot and one dongle at home. But you go to an event and there's kind of particularly like a competition where there might be kind of 10 people all with the same controllers and dongles. You turn your controller on, it'll pair to the nearest robot it sees, which might not be yours, or somebody else turns their controller on and pairs to your robot and drives it off the table. So
that sounds like fun chaos.
Yeah. So kind of the Bluetooth-based controllers are my preference. And
are you using a Python library to translate the Bluetooth control into robot control?
Yeah, so I wrote very early on in my kind of robotics, and this is actually one of my first robots that I built, again, based on Pololu tracks, but this was kind of their chassis kit. And then the hardware was kind of custom put together on top of it. I wrote a Pi game based robot controller library, which has been on GitHub and is updated as I add kind of new controllers. So if you go to github.com/footleg, you'll find all of my stuff there. And that Pygame library deals with interpreting the joystick, but it provides a nice kind of graphical interface to show what the joystick outputs are, which helps debug. And then as you move on to more sophisticated robots, if I just switch my camera to the desk camera, is that going to work?
Oh, Michael asks, what are the batteries you're using in triangle tracks? Are those double A's?
Right. So just let me see if I can get my... For some reason, my camera is no longer switching modes.
Curse of the live demo.
So this chassis is actually designed to take AA batteries, but AA's generally aren't quite enough. And so what I've done is inside, there's actually a pair of the lithium ion 14, forget the number, 14850s, I think. They're essentially AA size lithium ion batteries, but you only need 2 of them to get the voltage needed for driving the robot. And so with a spare space where the other 2 batteries would go, I've got a little UBEC circuit that gives me the 5 volts, regardless of what state of charge we have on the batteries. So that was my solution for that early robot. But what I wanted with this was something that I can just whip out and chuck in a charger. And these are, the form factor for these is NPF550. Possibly see it on the camera there. And they're a standard form factor that are used for a lot of video accessories. So I believe they were originally a Sony camcorder battery, but now most of the kind of LED panel lights that are used for video, these slip on the back. And what I've done to build the battery holder is actually taken the charging plate from a charger, because it was cheaper than actually 3D printing and doing my own kind of contacts. And that battery plate is integrated into the 3D printed design, and then the robot, the battery just slots in. So
very nice.
It's a 7.4 volt lithium battery.
How long does it last for usually?
This one will go a good 3 to 4 hours at an event from its experience at Liverpool Makefest this year. So it's a fairly low power robot. Higher power robots maybe a couple of hours, but it's plenty of time for driving around, and you can just whip it out and stick another battery in as soon as it's run flat. So
yeah, that's not bad at all.
Yeah, that's really cool. I'm sorry. So you were saying about some of your other robots that you're working on?
Yeah. So the one that I was trying to get the desk camera to show you is this, which I designed for the Pi Wars competition in 2019. And it's designed based on the NASA rocker bogie suspension that the Mars rovers use. So
wow.
This kind of design where kind of as one side pivots, this arm on the top pivots the other side, and then there's a second hinge. It means that no matter what terrain the robot's on, all 6 wheels are always in contact with the ground.
That's wild.
And it's using the same code, but because I'm using Pygame, I've also got the advantage of having access to a graphics interface. So it's got a touch screen on the top, and I built the menus out of all the planets. And if I select one of the planets to put it into drive mode, make sure I pick the right one, then it masquerades as a solar panel.
That's really neat.
And then I can switch back to the menus to kind of put it into different modes, the different competition kind of modes it had at the Pi Wars. And another thing which kind of I brought from my professional life is I've also got like a digital twin of the robot on the robot. And I don't know if you can see that, the distance sensor at the front, it shows its output.
Neat. Yeah, we can see it.
And the idea of writing a digital twin is that I can then code the entire robot without having the robot. So all of the control hardware, menus and everything I could do in a Python program. And it just kind of outputs a virtual representation of the robot, a very simple one, but effective. And then I can drop that code onto the actual robot, and I know it's going to be up and running and work just like the code that I've been testing. And it's really nice to be able to kind of take your kind of code away from the robot, so you can work on it on a laptop anywhere, and then stick it on the laptop when you're ready to on the robot when you're ready to test it.
I've never seen a robot like that one before. That's really, really cool. Was the frame for it, was that a laser cut acrylic, or how did you construct it and design it?
I designed it all in CAD using SolidWorks and laser cut all the acrylic at MakeSpace, which is where I am tonight. I'm borrowing the MakeSpace video kit.
Lucky.
That's awesome. So everything that you've shown us now is powered by what, a Pi 4, or what's the board?
So the oldest robot, this one, has a Pi 0, the original Pi 0, Pi 0W to get the Bluetooth. This newest one is using the Pi 02W, just because it boots up a bit faster. You don't really need a faster Pi for a robot like this, because all it's doing is translating kind of human thumb controls on a joystick into motor action. But I've got more processing headroom there. So this one's got an audio circuit that the Inventor Hat provides. So I can start playing audio samples and kind of extend it with more hardware, potentially add a camera, and then you start benefiting from a faster Pi. This one has actually a compute module 4 in it. And then the reason that this originally was a Pi 3 robot, and I moved to a Pi 4 compute module because the carrier board it's using, which is a WaveShare board, has all of its ports on one edge. So the HDMI, USB, and the Ethernet all come out the back, which is really handy to be able to plug anything into it because the ports are all accessible.
Yeah.
That makes sense.
Have you done any robots with a Pico or the Raspberry Pi Pico?
I haven't yet because of the remote control issue. That it wasn't possible to pair Bluetooth remote controls. Now that looks like it's just about becoming possible with the new Bluetooth support in the Pico W, and I think that's really going to open up the world. I would love to build the robots with the Picos, because one of the problems with, particularly with the Pi 0 robot, when this one crashes, and it sometimes when it gets a hard knock, it causes the Pi to crash. I think it's a battery connection issue. So the batteries are held in springs. And I think when it's hit hard enough, it just gives enough of a power outage to kind of sometimes crash the Pi. It takes a few minutes to reboot because the Pi 0 has a really slow boot up time. Whereas if it was a Pico, then it would literally be flick the power switch and we're up and running again.
Yep. Especially if mainly what you're doing with it is remote control. But I know it's been difficult so far. I think there's a MicroPython library for Bluetooth now, but I don't think I understand it's pretty difficult to use.
Yeah. So a project I've not brought down tonight, but what I've been working on is actually building a remote control using ESP32 boards and using the ESP Now protocol, which is a peer-to-peer protocol that Expressive developed specifically for their boards. And it connects using the MAC address of the board. So literally in faster than you can kind of see with the human eye, it will make its Wi-Fi connection. And I've managed to get a range of over 120 meters with that.
Cool.
So that's going to be good enough for kind of my kind of robotics needs. And I'm planning to convert some of my robots over to use ESP32 boards for that reason. Because that Wi-Fi peer-to-peer protocol is so effective for a robot control.
So you're gonna replace the Raspberry Pi board with an ESP32 board, and then you're gonna have another ESP32 board that's used for the remote control?
That's right, yeah. So I've been designing a remote control with some nice 6-axis joysticks and a SPI color LCD screen. And the idea is I'll have menus on the remote, which will show me all the robots that it knows about and which ones are online it can see. And then I'll be able to pick the robot and control it. So I'll have because I'm able to write the code, I'll have a lot more control over kind of how the remote control behaves. And I think that would be really nice. But I've done the kind of prototyping, I've done the range test. I just need to finish the 3D print design for the console and build it.
That sounds awesome. It's really hard. I mean, I haven't seen any really good designs, at least out in for a remote control like that. So that would be fantastic. That would be fantastic. When you finish it, do you plan to share the STL files?
Yeah, I'll probably make that an open project because it's not something I'd ever be looking to try and kind of make a kit out of. I think it would be a good community project to just put out there for other people to benefit from.
Yeah, that would be awesome. I would love to make kind of a universal controller. Why ESP32 instead of using something like Pico or another Raspberry Pi?
Just because the ESP now peer-to-peer Wi-Fi protocol is expressive kind of proprietary protocol, which only works on their ESP32 boards.
How different is that from just using regular Wi-Fi direct?
So you don't need any kind of host or kind of, you could probably do something with a Raspberry Pi and make it as a hotspot. The Wi-Fi, I think, is kind of slower to pair and connect, and I don't think the range is there. The ESP Now protocol has a long range mode where it kind of essentially reduces its bandwidth in order to get kind of consistent communication over range. So literally with kind of like one of those little aerials that's a kind of stick aerial about that long, you can get 120 meters range and possibly more range, but it's line of sight, and I couldn't get more than 120 meters away from my test rig when I was playing with it to kind of see how much further I ran out of space where I was testing it.
Very cool. So are you doing anything with object recognition or any type of machine learning on your robots?
It's been on my to-do list for an awfully long time, but I've not yet actually taken the plunge with that.
What would you like to do?
I'd like to make a robot that interacts with people at events, so something that can sit on the desk, recognize faces, and then kind of respond to people. So just track kind of their faces. It's a relatively simple programming problem because face recognition libraries are kind of freely available and seem to work very well. I just haven't had time to actually sit down and play with it.
Yeah, I'm thinking I would love to do something like that too, to kind of have it, a robot that maybe reacted, if it could recognize individual faces, sort of react differently to different people. Would be pretty cool. Let's see. We have a question from Bill. What autonomous robots have you worked on?
So the only autonomous code I've actually written, and I use it in the loosest sense of the word, is on this robot, where I had some attempt at using the distance sensors. It used to have a distance sensor mounted on each side, but they've currently been borrowed for another project. But that was to essentially do a kind of speed run at Pi Wars competition, where it was trying to measure the wall distances and keep the robot equidistant between the walls. I didn't get the PID tuning working very well, so it kind of bounced off the walls a bit and rattled down the course and just about completed a run. But because I'm constantly designing and building kind of the physical side of the robots, I really haven't put a lot of time into building autonomous code for actually controlling them. I keep on kind of building more and more robots. So just to show you some other examples, this is what I call my Turbo Tiny robot. So this was based on the Cortec Robotics Tiny kit, but I changed the form factor slightly to fit my batteries. So I've got a couple of lithium-ion 18650s in the back there. And it was also a test bed for my own hardware. So the board that you see on the top is a robot control hat that I designed actually for the orange Mars rover robot.
Nice work.
I kind of use it in my other robots because once you've designed the board and made a few of them, it's kind of like my go-to hardware of choice for my own robots. But I also do a lot of prototyping. So this is kind of an example of my prototyping rig. So I'm using 1550 extrusion to make a frame. And then I've got a GoPro camera mount. I've got these adjustable position motor, kind of motor brackets. And for this one, I actually designed 3D printed tracks. So
that's really cool.
I called this my my drift tank, because these are PLA and they're kind of sharp edged, so they're great on carpet. But if you put them on a kind of shiny floor, a smooth hard floor, it's got no grip at all, and so it drifts really, really well. It kind of you drive it along at high speed, and when you try and turn, it just carries on sliding in the direction it was going.
That's really cool.
That was a lot of fun, but obviously I wanted to solve the grip problem, and so I got into multi-material 3D printing. And so here is its big brother. And you can see these tracks have got a kind of rubbery texture. So these are PLA and TPU, two different types of 3D printed filament. The TPU is the kind of semi-flexible, and so that gives a little bit more grip. So that's kind of been built but not yet wired up. It's much more powerful motors on this one, and I've not taken it to any events, because just testing these motors on my bench power supply, it was very apparent that any finger that got into these tracks would just get kind of mashed around. You wouldn't want your hands anywhere near this when it's powered up. But the idea with this was to have something I could drive around the garden with enough torque that it didn't get kind of bogged down in long grass and gravel.
Yeah.
So
and it looks really cool.
Robots and the kind of autonomous code side of things has taken a back seat so far.
Oh, cool. Yeah, I can understand that. I mean, it's those robots look fantastic, and it's really a lot to be proud of. So what would you recommend to folks who are kind of just getting started with building robots? Would you recommend a particular kit? Would you recommend a particular design? What's the best way to get started with designing robots like that?
So I would definitely start with a kit if you're starting out with robotics. There's a bunch of really nice kits. I started with the CamJam EduKit 3, which is at the kind of cheapest end of Raspberry Pi robotics I think you can get. The cardboard box it comes in becomes the chassis of the robot, and it has a couple of motors and a caster wheel at the front, available from all the usual suppliers. That's a great kind of getting started if you're really starting from the basics, because what I found was as soon as you've kind of dipped your toe in the water, you learn so much that it changes what you want to do. And so you don't want to spend a lot of money on an expensive kit for your first robot, because you might outgrow that robot almost as soon as you finish building it. The next kit I would really recommend is the one, it looks very like this, but this is my own kind of build of it, but the Cortec Robotics Tiny 4-wheel drive, which has 4 of these motors, same sort of wheels, Pimeroni sell those, and it's a really capable robot. So it copes with kind of going up kind of steep slopes and kind of bumpy terrain for a little robot. A lot more fun than the kind of 2 wheels and a caster wheel style. And kind of having built a couple of kits, you'll have had to solve the problems which I've kind of tried to solve with these robots, which is how am I going to power it? Because you typically don't get a battery in the kit. You get the motor driver, you stick a Raspberry Pi on, and then you've got to think, well, how am I going to provide power to that? And the simplest way is 4 AA batteries, but they don't have a lot of current for driving motors. So you might move to nickel metal hydride batteries and then be thinking about lithium batteries. And now you start to need to understand power regulation and kind of safe management of lithium batteries, and things become more complicated. And that was the motivation behind this robot, is that it uses an off-the-shelf battery. So the battery is kind of safe for charging and easy to handle, and easy to get hold of. You can go to buy them from most kind of suppliers that sell camera batteries, so easy to find.
Yeah, powering is definitely a huge challenge. Have you done any robots with cameras?
So there is a camera on the front of this one. It's actually the Pixie Cam, which was I think an open source hardware project, and it has kind of color and object recognition built into its hardware. So there's a Python library which will work out what objects are in the scene. So it's fitted on there, but I never actually got round to coding it, and it's still on the to-do list. The robot had a lot of other problems that needed fixing first. One of which was that the internals were it was so densely packed with wires that it was impossible to take apart and maintain. It took kind of about sort of 2 hours to get the Raspberry Pi out and all of the kind of wiring between the breakout boards. And that was what kind of got me onto PCB design. And this was the first PCB that I made. And it's essentially all of the hardware that I had on breakout boards, but mounted on one hat. And it also, if you kind of, the way that the Raspberry Pi header is in this direction, and you can see it's got a Raspberry Pi GPIO header at 90 degrees to the main header. And that was so that the ribbon cable didn't have to be kind of twisted and folded back on itself to kind of fit in the case with the screen, the touch screen.
Right.
So now the kind of ribbon cable is kind of like in one concertina, which means you can pull the electronics out the back of the robot and kind of access them without all of that density of wires. So a lot of kind of redesign work went into just the physical wiring problem. And of course, along the way, I learned KiCad PCB, making my own PCBs via hand soldering surface mount components. So it was about kind of 2-year project learning a lot of new skills that kind of took me forwards as a maker, but I didn't get to the kind of coding side because I'd spent all my time on learning those physical making skills.
That makes sense. So, Ash, I know you've been quite busy. Are there any projects you've been working on lately, or anything you've seen that's really cool?
I don't have anything pulled up today, but it's almost the end of the month, and we're going to have a big list of Raspberry Pi projects for our Projects of the Month post in the next couple of days. So next week I'll definitely show off some of those, but you can keep an eye on tomshardware.com for that list to come live in a few days.
Yeah. So who do you, so Paul, who do you follow? Who are some of the folks that you would recommend people keep an eye on for doing fantastic projects?
So probably the person who seems to have produced the most output of anyone I know is Kevin Mercallier, who is just prolific in posting his, it seems every week he's built something new. So he's producing some really cool robots.
Yes.
I'm good friends with Brian Corteil, who I think you've had on the show a few times recently.
He's in the comments too. He's watching.
Yes. Yes.
Hi, Brian.
Yes. But Kevin we've also had on the show. Yeah, those guys are doing fantastic work.
I'm surprised Kevin's not in the comments because he's so into robots, as you said.
Over in the US, I've been really inspired by the kind of companion robots that OddJ has been producing.
Oh yes, we had him on once. Oh, what a brilliant guy! I love the robots that he like wears them like a parrot. Yeah, amazing. Yeah.
And a lot of kind of other people I follow are for kind of really learning more technical skills. So I follow quite a few 3D printing YouTubers, really more to find out about the capabilities. I've got a collection of 3D printers at home now. My latest project has just been a complete rebuild where I've 3D printed a new hot end and enclosure panels to enable me to print kind of more exotic filaments. So that's kind of, and that's also my first printer that's running Clipper. So it's got a Raspberry Pi with the 7-inch touchscreen. So I've got a nice full color touchscreen for controlling the printer when I'm at the printer, but I can also open up the web browser with the Fluid interface, and I can kind of slice my prints and send them to the printer over the network at home. No longer have to stick SD cards in to move my files around and kind of tune in. And I'm just starting to kind of scratch the surface with the capabilities there. So that's been a really nice Raspberry Pi and 3D printing project. It's brought a lot of things together.
Roland asked, what is the function of the luster terminals below the time of flight sensors?
So this robot was built for the Pi Wars competition, and it's actually just a bit of kind of what we call chock block for joining electrical connections. But it's the standard Pi Wars competition connector that every robot has to have on it to mount the attachments for some of the challenges. So one of the challenges is what's called Pi Noon, where two robots kind of compete head to head. The whole point of the Pi Wars competition was to create a robot wars-like competition that didn't cause destruction of the robots, so that kids and kind of school groups could build robots and come and enjoy a competition, but not have to kind of go home in tears when their robots have been smashed to pieces. And so the only combat element to Pi Wars is an event called Pi Noon, where you have a pin mounted on the front of your robot and a balloon mounted on the back. And you have to try and pop the balloon on your opponent's robot before they pop the balloon on your robot. So the robots don't come to any harm, but it kind of tests driving skill and is a kind of good kind of knockout competition that runs. And to mount that kind of balloon and pin attachment, it's on a metal rod which goes into the chock block on the front of the robot. So that's why it's there.
I swear that has to be taken straight out of Mario Kart for the 64.
Indeed, that is a feature. Well, I want to thank Paul, Dr. Footleg, for joining us today. Where can folks go to see more of what you're working on?
So my Twitter handle is Dr. Footleg, Dr. Footleg, and that's where I post the vast majority of my stuff. I have a blog I update occasionally, which is kind of linked in the Twitter bio. I'm also kind of scratching the surface on Mastodon. I'm not as active on there as I could be, but again, if you go to my Twitter profile, then my Mastodon username's on there. I'm Dr. Footleg kind of everywhere. So if you Google Dr. Footleg and exclude all the chiropractic clinics that come up, then everything else on the internet is about me.
Yes. Well, thank you so much. Thank you so much for joining us, and thanks to everybody for watching and listening. We will be back next Tuesday, the 5th, at the same time, 2 p.m. U.S. time, 7 p.m. UK time, and we will see you all then. Thank you so much.
And thanks for having me.